Have you ever stopped to think about, the hidden stuff, the innovations working away behind the scenes? Things that make sure your water's clean or like your food is mixed just right every single time. It's actually pretty amazing when you think about it. Today, we're doing a deep dive into one of those areas. It's called the global jet mixer market. Sounds super specific, I know, but as we'll see, it's absolutely vital for tons of industries we rely on daily.
It really is. Jet mixers, they're critical pieces of equipment for industrial mixing, for processing fluids. Think efficient blending, circulation, getting things properly mixed. And they're crucial in sectors like, well, chemicals, water treatment, food processing, lots of places.
Okay, right. Jet mixers. So let's unpack this a bit. What actually makes them special? Why are they so important?
Well, the core idea is pretty smart. They use fluid dynamics. Instead of, say, big mechanical stirrers inside a tank, they create these high-speed jets of the liquid itself to do the mixing. Imagine using a strong jet in a pool to circulate the water. This is kind of the principle. No moving parts inside the tank.
Ah, okay. No moving parts. That sounds like a big deal.
It is. It means less energy use, much less wear and tear, easier cleaning. It just makes the whole process more efficient and often cheaper in the long run.
Yeah.
And you get a really uniform mixture. That efficiency and scalability, that's what's driving their growth globally.
Efficiency, scalability, reliability. Got it. So our mission here for you listening is to wade through the data from this market report, pull out the key insights, and talk about this surprising growth and what it really signals for industries worldwide. So let's kick off with the big global number. Cognitive Market Research says the market hit about $316 million back in 2021.
Yeah, $315.995 million to be precise. And what's really interesting is the projected growth from that point. It's forecast to hit almost $390 million by 2025.
Okay.
And then jump significantly to nearly $594 million by 2033.
Wow.
That's a compound annual growth rate, the CAGR, of 5.4% for that 2025 to 2033 period. And what's fascinating, like you said, is how steady that projected growth is. It really points to strong underlying demand, a real need for this technology.
A solid 5.4% growth globally. That's definitely significant. But the global picture is one thing, right? Let's break it down regionally. And this is where it often gets really interesting. How does this play out across different parts of the world? Maybe start with North America.
Okay, North America, it's the biggest player right now. Back in 2021, the market there was worth around $128 million.
Right.
That's expected to rise to about $156 million by 2025, and then keep climbing to over $232 million by 2033.
Still growing steadily then.
A CAGR of just over 5%, 5.109% to be exact. And the U.S. is the giant within that region, no surprise there. The U.S. market alone was about $103 million in 2021, heading towards $124 million in 2025, and projected to hit $180 million by 2033.
So the U.S. is driving a lot of that North American figure. What about Canada and Mexico?
They're smaller markets, naturally, but showing good growth too. Canada was around $12.7 million in 2021, expected to reach $16.5 million in 2025, and over $26 million by 2033. Mexico is similar, starting at about $12.8 million in 21, growing to nearly $16 million in 25, and projected at $26.5 million by 2033. So solid growth across the board there.
Okay, so North America is strong and steady, led by the U.S. Let's shift focus across the Atlantic. What about Europe, another major industrial region?
Europe's another key market. It stood at roughly $81 million in 2021. The forecast sees it growing to over $98 million by 2025 and then hitting nearly $148 million by 2033. The CAGR there is actually slightly higher than North America, around 5.2%.
Interesting. And who leads the pack in Europe?
Germany. Definitely Germany. It's the industrial engine. They were in nearly $20 million in 2021, expected to be around $24 million in 2025, and pushing towards $35.5 million by 2033.
Right, that makes sense given their manufacturing base and other big European economies.
Yeah, we see consistent growth elsewhere, too. The UK, for example, started at about $8.2 million, projected to reach $10.5 billion in 2025, and nearly $17 million by 2033. France was a bit larger, almost $12 million in 21, growing to over $14 million in 25, and forecast around $20.6 million by 2033. Italy, around $7.9 million in 21, projected $9.1 million in 25, and close to $13 million by 2033. And you see similar upward trends in, places like Spain, the Nordics, Switzerland. The rest of Europe category also shows solid growth, moving from $11.4 million to over $25.5 million between 2021 and 2033. It's widespread adoption.
So Europe's showing that consistent, maybe methodical upgrade cycle.
Right.
Now, let's pivot to Asia Pacific, often seen as a major hub of, well, current and future industrial growth.
Absolutely. And the numbers reflect that dynamism. Asia Pacific was valued at about $66 million in 2021.
Okay, smaller than North America or Europe initially.
Initially, yes, but look at the forecast. It's estimated at over $83 million in 2025 and then expected to really accelerate, reaching over $130 million by 2033. And here's the key thing. It boasts the highest regional CAGR, nearly 5.8%, so fastest growing region.
5.8%, okay. That's notable. And I assume China plays a big role there.
A huge role. China is the leader by far in APAC. It was almost $27 million back in 2021, projected to be over $33.5 million in 2025, and then racing towards $52 million by 2033. That's a massive growth, driven by, well, infrastructure, manufacturing upgrades, water treatment needs.
Makes sense. What about other key players in Asia Pacific? Japan, India.
Japan shows steady growth, too, from around $8.8 million in 21 to nearly $11 million in 25, and projected close to $16 million by 2033. They value that precision and efficiency. India is another one to watch. Started at $6.7 million in 21, expected to hit $8.6 million in 25, and forecast to reach over $14 million by 2033. Rapid industrialization is a key factor there, and we see similar positive trends across South Korea, Australia, Singapore, Southeast Asia. The whole region is clearly adopting these technologies quite rapidly.
So APAC is definitely the growth hotspot. Okay, let's cover the other regions. What about the developing markets, starting with South America?
South America, while smaller in overall value, is still part of this global growth story. It was valued around $14.2 million in 2021, projected to rise to about $17 million by 2025, and then reach nearly $26 million by 2033.
And the main driver there?
Brazil leads the way, accounting for roughly half the market. So Brazil was $7.1 million in 21, expected $8.4 million in 25, and heading towards $12.6 million by 2033. You also see steady gains in Argentina, Colombia, Peru, Chile, a lot of it tied to resource processing, food and beverage, and general infrastructure improvement.
Oh, got it. And next, the Middle East, often a region with big infrastructure spending.
Exactly. The Middle East market started at around $13.3 million in 2021. It's projected to hit nearly $17 million by 2025 and reach almost $27 million by 2033. So it's expected to more than double over that longer period.
And who's significant there?
Saudi Arabia is a major player. It accounted for about $4.7 million in 2021, forecast to grow to over $6 million in 2025, and break $10 million by 2033. Again, think large-scale projects, industrial diversification, and especially water management, which is critical there. Turkey, the UAE, Egypt, Qatar also show consistent growth.
Right. Water scarcity would make efficient mixing tech very valuable. Okay, finally, let's look at Africa.
Africa, starting from the smallest base, recorded about $12.6 million in 2021. But the projected growth is quite strong. It's forecast to increase to nearly $18 million by 2025 and then reach over $30 million by 2033. That's more than doubling, too.
And within Africa?
Nigeria is the leader. It was almost $6 million in 2021, projected $8.4 million in 2025, and forecast to hit nearly $15 million by 2033. This is driven by things like urbanization, growing industries, food processing, water infrastructure needs. So then Africa and the rest of Africa also contribute to that upward trend. There's clearly growing demand across the continent.
Okay, we've toured the globe, looked at all these numbers. So stepping back, what does this all really mean? What's the big takeaway when you piece all these regional stories together?
Well, if you connect all these dots, the big picture is pretty clear. The demand for efficient, reliable, scalable mixing isn't specific to one region or type of economy, it's universal. It reflects this fundamental global trend towards optimizing industrial processes, becoming more energy efficient, ensuring quality, and scaling up production.
So it's not just a niche tech, it's tapping into a core industrial need.
Exactly. Whether it's advanced chemical plants in Germany, massive water treatment facilities in China or the Middle East, or growing food processing needs in Africa and South America, they all need better mixing solutions. The consistent growth across every single region really highlights how fundamental these jet mixer technologies have become. They're essential enablers for modern industry.
It really is incredible. A technology like jet mixers, something most people probably haven't even heard of, is just quietly, deeply embedded in how so much of our modern world works, ensuring quality, saving energy.
That's the main takeaway, I think. As industries everywhere push for smarter, more efficient, more scalable ways of doing things, this market isn't just growing, it's becoming indispensable. The numbers we've discussed, they clearly paint a picture of a global shift towards more effective industrial processes, and jet mixers are right at the heart of that.
Well, thank you for walking us through all that data. It's been a fascinating deep dive.
My pleasure. And maybe just a final thought for you, the listener, to ponder. We've talked about jet mixers today, this sort of unsung technology. It makes you wonder, doesn't it? What other crucial innovations are out there, silently shaping our world, driving progress in ways we don't even realize, hidden away in the corners of global industry? Where else is that kind of quiet revolution happening?
You know, it's funny how some of the most vital industrial processes just happen quietly, right?
Yeah.
Often totally out of sight,
Hmm.
but they're absolutely fundamental to our daily lives. Think
Yeah.
about all that hidden machinery. It ensures everything from, I don't know, the food we eat to the water we drink is
Yeah.
just right.
Yeah, there's a real sort of quiet power at work there.
Exactly. Quiet power.
It's pretty remarkable how these unsung heroes operate. Their efficiency, their reliability. I mean, that's what enables so many things we just take for granted.
Totally. And today, we're actually pulling back the curtain on one specific powerhouse, the jet mixer.
Ah, yes.
Have you ever really thought about how these massive tanks full of liquids, you see them in food processing, chemical plants, wastewater treatment, how they get perfectly mixed
Right.
without, giant stirring arms splashing around everywhere?
It's a great question. It seems simple, but it's a real engineering challenge.
Right.
And that's precisely what you're going to dive into today. In this deep dive, we'll pull out the core insights from the research we've looked at. We want to reveal how these, let's call them industrial workhorses, actually function, understand why demand is picking up so much.
Mm-hmm.
Look at the challenges they face naturally and pinpoint the innovations shaping their future.
So the goal is really to give you, our listener, a concise but, thorough understanding of this maybe surprisingly crucial
Yeah,
technology.
exactly. From wastewater plants, which are obviously critical, to cutting-edge biopharma labs, jet mixers are quietly doing essential work all over the world.
And our research definitely shows their demand is climbing. Pretty significantly, actually.
It is.
So let's get into it. What exactly is fueling this momentum for jet mixers? What's the big driver?
Well, what really stands out, I think, is the growing need for super effective mixing,
Right.
especially in really, really large tanks.
Okay, large scale.
Yes, and jet mixers just excel there. They work by generating these powerful circulation patterns using fluid that's pumped back into the tank.
Right.
And the key thing, this achieves incredibly uniform mixing without any internal moving parts inside the tank itself. Not at all.
Okay, no internal moving parts. That sounds fundamental. I mean, beyond just fewer things breaking down, what does that specific design actually allow for that maybe traditional agitators can't handle?
Hmm.
Does it open things up for like really abrasive stuff or guarantee that, super sterile environment needed where seals might be a contamination risk?
You've really hit on a critical point there, that core design. It doesn't just minimize wear and tear, which, directly means less maintenance downtime, lower energy costs compared to those big, complex mechanical agitators.
Sure, makes sense.
But it also makes cleaning much, much easier, and it means fewer points of potential failure in those really sensitive applications.
Okay.
Yeah, it's basically a winning combo for industries that are just relentlessly focused on boosting efficiency and cutting down those operational costs.
And I noticed our source material also really highlights their use in wastewater and slurry management. That sounds like a particularly tough but vital area.
Oh, absolutely vital. Yeah. Facilities dealing with thick sludge or abrasive slurries, maybe liquids that need aeration, they depend heavily on jet mixers.
Why is that?
It's their unique ability to stop stuff from settling out sedimentation and to keep solids evenly suspended. That isn't just, helpful. It's often absolutely essential for effective environmental engineering and treating industrial waste properly.
Right, keeps everything running smoothly,
Exactly.
efficiently.
Okay, so this raises the obvious question then. If they're so effective, what are the trade-offs? Because, nothing's perfect. There are always limitations in any market.
Indeed. And the research does point to a pretty significant one.
I hear.
Their high dependence on external pumping systems.
Yes, I saw that. That's core to how they work, isn't it?
Yeah.
Jet mixers don't create velocity on their own. They need that external pump.
Precisely.
So that adds, extra complexity, right? And cost. Especially if an operation doesn't already have the right kind of high-capacity pumps needed.
That's right. It adds layers. Pump infrastructure isn't always cheap or simple to integrate. And it must directly impact the energy use over the long term and just the whole system design thinking.
Absolutely. It's a major factor in the overall equation.
Okay. What about the fluids themselves? Are jet mixers sort of universally good across all liquid types? Or are there limits there too?
Good question. Not entirely universal, no. Another key limitation is their reduced efficiency when you get into highly viscous fluids.
Ah, like thicker stuff.
Exactly. Jet
Yeah.
mixers really shine with low to medium viscosity liquids, but when you introduce thicker materials or what they call non-Newtonian substances, fluids where the viscosity changes with agitation, I think paint, maybe some food products.
Like ketchup.
Kind of, yeah.
Yeah.
Their mixing effectiveness can drop off quite a bit.
Okay.
So in those specific cases, sometimes the old school mechanical agitators might actually be a better fit.
That clarifies things. So it's not a one-size-fits-all solution.
Definitely not.
And then there's the point about the initial design complexity, the need for customization. That sounds like it could be a barrier for some companies.
It certainly can be. I mean, the reality is every tank is different. Every fluid behaves differently.
Yeah.
Every process has its own specific needs.
Right.
So designing a jet mixer system that perfectly matches a particular application often requires, well, significant specialized engineering work.
Which translates to longer lead times, maybe higher upfront costs.
Exactly. And that might be tough for smaller businesses or perhaps operations with really, really niche mixing needs.
Okay, so we've kind of laid out the challenges, but despite these hurdles, you said the market is still growing.
Yes, definitely trending upwards.
That suggests there must be some powerful innovations really driving this growth. So what are these sort of transformative trends shaping the future here?
Well, a really prominent one that jumped out from the sources is their increasing use in biopharma and other sanitary applications.
Like biopharma.
We're talking about hygienic jet mixers, usually made from stainless steel, designed to be fully compatible with clean-in-place or CIP protocols.
And maybe just explain for our listeners, why is that clean in place thing so important, especially in industries where, purity is everything?
Oh, it's absolutely critical.
Yeah.
CIP protocols are essential to prevent any kind of contamination and ensure product safety. Think food, pharmaceuticals,
High stakes.
very high stakes. Jet mixers, because they don't have those internal parts cluttering the tank, make this cleaning process much easier, faster, and more reliable than trying to clean around complex internal agitators.
Ah, I see.
It drastically cuts contamination risks and helps deliver really consistent, precise results batch after batch, which of course aligns perfectly with the incredibly strict regulations in those industries.
Okay, yeah, that sounds like a genuine game changer for those sectors.
It really is.
And with all of this advanced capability, I'm guessing automation is playing a bigger role too.
You guessed right. Definitely. Another crucial trend is how easily they integrate with sophisticated process automation systems. Well, jet mixers are increasingly being hooked up to all sorts of sensors, digital controllers, allowing for real-time monitoring of flow rates, even predictive maintenance alerts.
Ah, predicting problems before they happen.
Exactly. And just giving much, much better operational control overall. In this whole context of, smart factories and Industry 4.0, that level of data integration is a huge driver for boosting productivity and reliability.
That makes perfect sense. Very forward-thinking. Okay, and lastly, you mentioned customized jet nozzle technologies. That sounds like where the real fine-tuning happens.
It is indeed. That's the precision engineering element. Innovations like variable angle jets or nozzles that can point in multiple directions.
Cool.
These are significantly boosting both the flexibility of the mixing and the overall performance.
So you can tailor it much more precisely.
Precisely. These advancements let engineers adapt the mixing very accurately to different tank shapes, different liquid properties, really complex process needs. It just broadens the usefulness of jet mixers into even more intricate industrial scenarios.
Fascinating. So considering all these advantages and innovations, who are the key companies leading the charge in this jet mixer market? Who should we be aware of?
Well, the source material points to a mix, really. You've got some established global players alongside more specialized manufacturers.
Okay.
The list includes names like GEA Wigand, Alfa Laval, Xylem Inc., Fluco, Paul, Medico, Sharp, IK, Funkin, Zonji Chemical Machinery, Bob G Valve, Kidong Great, TINC, and Dry Machinery Equipment. Quite a few key players.
That is a comprehensive list. Seems like a competitive space. What are the general strategies these companies are using to, stay ahead in this evolving market?
It seems pretty consistent across the board. They're investing heavily in R&D research and development,
Makes sense.
really pushing the boundaries in areas we just talked about. automation, better nozzle designs, that sanitary engineering aspect.
Hmm.
And many are also expanding globally, through strategic moves like mergers, partnerships, and just continually rolling out new product innovations. It's all aimed at staying competitive in a market that, as we've seen, increasingly demands both high precision and solid reliability.
And there you have it, a pretty comprehensive deep dive into this, well, fascinating, but often kind of unseen world of jet mixers, drawing out those key insights. What an illuminating discussion.
Yeah, it really was.
It just underscores how these jet mixers, even though they operate, behind the scenes, are such a vital force in the whole industrial landscape.
Mhm.
They really represent this convergence of like advanced tech, operational efficiency, and that custom engineering touch we talked about, all designed to meet these tougher and tougher industrial needs.
Yeah, we definitely cover their core advantages, that
Yeah.
uniform mixing in big tanks, the energy efficiency, the lower maintenance needs,
Right.
and then those exciting future trends, from biopharma adopting them to the integration with automation and those really smart customized nozzles.
And it really makes you think about the broader impact of these kinds of specialized industrial technologies, doesn't it?
Yeah, it does.
These advancements in machinery that most people never see, they contribute directly to the safety, the efficiency, the innovation of countless products and services that, well, that you interact with every single day, often without even realizing the complex engineering humming away in the background.
Absolutely. And maybe that leaves us with a final thought for you, the listener, to mull over.
Okay.
If seemingly simple-sounding components like customized jet nozzles or integrated automation can fundamentally reshape entire industries and help tackle big global challenges like managing wastewater, well, what other quietly powerful technologies are out there, just sort of waiting for us to uncover their full potential?
Mm.
It's worth thinking about all the hidden ingenuity that's woven into the world all around us.